Hi, I'm Tim with the Motion Toronto Custom Team. We recently incorporated a basic 3D printer to our department, and I've been asked to demonstrate ways we're using it in our work.
I think everyone has heard of 3D printing. You've likely seen printed toys, fidgets, and doodads for sale, but many people don't really know how it works, so here's a quick introduction. The printer itself uses reels of a filament that's pushed through a heated nozzle and laid down in precise patterns layer by layer. Think of a hot glue gun merged with an Etch-a-Sketch with micromillimeter precision. The main filaments I use for work are PETG when I want rigid, tough parts, and TPU for tough, flexible ones. Here's a recent example of a project that incorporated 3D printing. I've been asked to make leg supports for bone density clinics several times in recent years, and part of the original sample I was given included a foot cup that's become difficult to source, so I had to make something to replace it. The way I did this with our traditional workflow was to make a template, cut ABS to the pattern, smooth, heat, and shape it. Then, since it was a bit rough inside, make foam liners and sew neoprene covers to finish. This all takes time and several types of equipment, and since I need multiple pieces, the whole process has to be done over and over again. You can imagine that it becomes a pretty big repetitive job. I was starting to make them again this year when it occurred to me that this could be an ideal application for the 3D printer. In this case, it involves sketching a shape with relevant dimensions in 3D modeling software, then extruding, trimming, and rounding the shape as needed. The file is then open in what's called slicer software. To turn the shape into instructions for the printer, a few parameters are selected to specify how it's going to be made. Then simply press print to send it to the printer. If I need more than one, just press print again. If I'm asked for different size, I can simply adjust the dimensions in the original sketch to update the model. For spacers, tube caps, joystick knobs, and other small parts, this is a very efficient way to work. Need spacers for mounting flat custom backs to permeable plates? You could make spacers by hand from ABS or Nylotron, or stack washers to make enough of a gap to allow the latch to release. With a printer, it's easy to produce as many spacers as you want in whatever dimensions you need. Anterior leg straps mounted to the back of a calf panel. You could use a stack of washers or a chunk of ABS, or you can make a quick sketch, produce nice looking spacers for a finished look. The possibilities are endless, limited only by the imagination. In addition, files can easily be shared between multiple locations with printers. I love the idea of techs sharing designs coast to coast. The price of this equipment is much lower than most people think. This is still early days. These are our first tentative steps using this technology. I hope that in the coming years, it will be quite routine to print custom parts for clients, the same way we now do things like sew straps or make foot pads and trays.
Thank you for watching. If you have any questions for me about this, please reach out. I'm happy to hear ideas and suggestions and discuss ways we can use this in our work. Take care.